All right, everyone, looks like we're ready to get started. So, welcome. This is designing web APIs for long-term success, or possibly the ways we painted ourselves into a corner with our web APIs, or possibly the ways past Jeff screwed over future Jeff by not building things that were very good for future expansion. I'm currently a consultant at NimblePros, but I've been a professional software engineer for 25 years. I like to think in that time I've learned some things, so I thought it'd be fun to come and share some of those things that I've learned over the last 5 to 8 years. Mostly dealing with web APIs. I've got them, you've got them, internal facing, external facing, REST, GraphQL. They're pretty ubiquitous. Super easy to get started with. Just, most languages have something built in for request and response. Grab a popular framework, grab a 20-minute getting started video. Heck, just vibe code it and fix it later. Whatever it is, just get it out to production. Don't really worry about it. They're pretty simple things, right? And that's where I started too, but it isn't where I ended. So over the last, 5 to 10 years, dealing with multiple companies I've worked at, seen some things in our APIs that I think we could have did better over the years. I'm going to pull real-world examples from 3, but primarily 2 companies I used to work at that I'm going to represent with emojis to kind of protect the innocent. One will be Company Brain. These guys, I was there for like 8 years. This is a B2B enterprise SaaS vendor tool. When I started there, we had a whole bunch of different products that were all kind of built by siloed teams, and sales would go out and say, hey, I see you got a little bit of product A, you want a little bit of product B, and upsell for different products. But that meant these were all siloed builds. They all had their own database, their own authentication, their own API, possibly in a different language from the others. And over the years, the marketing and sales folks started merging it into one big product. You just bought Company Brain's product, and we could license off chunks of it as needed, but you could kind of access whatever. So it needed to merge into one big old API. Plus, over all those years, we just started doing API rewrites. But being enterprise clients, they're very risk averse. Our products were critical to the operation of our clients, so we could not have downtime mostly. Releases would take weeks of QA regression testing and need to be planned and communicated to our customers up front. And to keep things extra spicy, in the 8 years I was there, we went through 4 renames and 2 acquisitions, so that was fun. We had a lot of domain names floating around. Company Egg, on the other hand, is kind of some of the opposite. We have a whole bunch of internal REST-based microservices APIs, but they're pretty much just teams calling each other's teams microservice APIs. Still built by individual siloed teams that are kind of doing their own thing in their own language. There's at least 4, maybe 5 different languages in play across a lot of these services. Teams like to just go make changes to their APIs without necessarily telling anyone, and they try to keep things from breaking. But there's a lot more acceptance of risk in things breaking since it's all internal facing, and thankfully we can deploy as needed, so we could do multiple deploys a day if we really had to. So that's kind of where I'm going to be pulling examples from for a lot of this stuff. And so I'm going to have 10 things, really 9, that I ran into over the last 5 years-ish that caused me a lot of headaches moving through working at these 2 companies. Number 1 recommendation would be to actually document your API conventions. And this would be beyond just customer-facing documentation. Sure, you could auto-generate some Swagger docs that have some, sample request response to hand off to your customer so they know how to use your stuff. But I'm talking about internal teams when you have multiple silo teams building multiple APIs, building multiple products that are all trying to be somewhat coherent. Especially as you move towards things like microservices, where one of the big allures is that every team can use their own technology that they pick is best for their service. That also usually means people don't necessarily do things consistently. But you should be able to jump into a new team and figure out how their API is going to work without having to worry about what technologies they chose. So things like how errors should be handled, what your API response formats should look like. Documenting common property names becomes important later on as we get into things like observability, which we'll touch on towards the end. And even just how authentication tokens work. If you're using JWT tokens, what's even in those tokens? What do they define? How do you use them? How do you validate them? Basically trying to get all your teams to do the same thing. This doesn't have to be a horrible, tedious process, because I know nobody wants to do documentation, but there are things that exist. JSON API I found to be a really good one. It kind of defines a lot of everything. It's a pretty good starting point for internal-facing documentation. OpenAPI has a good mix of things in it, and Stripe, surprisingly, has a really awesome customer-facing documentation, but they have a lot of good examples of how they kept things consistent across all their APIs. So pagination, sorting, all that stuff is consistently done across their entire API, and it's actually spelled out really nicely in their docs. So at Company Brain, we didn't have any of this when we built our individual siloed applications, but years into the process, when I was starting to merge things into one coherent API to appear as if they're one product to our customers, I kind of got to the point where it was like, we need to document what our API is actually supposed to look like and not have every silo team doing their own thing. And I basically started with like a 3 to 5 page Word doc or Google Doc that was just, unless otherwise specified here, we're using JSON API standards. And that was a good enough starting point for the most part. And then as we ran into things we didn't like in that standard, we just, revised it as needed. At Company Egg, we have no such guidelines, which we'll see some fun examples of what happens later on. And this is the kind of stuff I'm talking about straight out of JSON API. This is their section on sorting. You have your may, must, should keywords that you normally have in specifications or RFCs. And basically every endpoint should use sort as the parameter name. Not order by, not sort by. Everyone should just use sort. So the next one, and something that should end up in your documentation, is to return objects, not arrays. And this is one where all of the boilerplate things just kind of gloss over it. Sure, just read some database records, JSON, serialize it, toss it back over the wire, and you're good to go. But this leaves you with a problem with arrays in that there's nowhere to hang additional data as your API evolves, and you need to add maybe some kind of metadata. Like you want to add pagination data, well, you can't just tack that onto an array. But if you had been returning an object, perhaps with the data field there, later on down the line, when you want to add pagination, you could tack on those properties without having a breaking change to your API. GraphQL, if you've been in that space, does this, I would say, correctly. Whether it's successful or an error, you get back an object. You'll either get a data field or an errors field, but it's at least always an object. And even without looking at the response code from the HTTP responses, you can tell what's a successful message, what's an error. It's easy to programmatically handle these things. If we look at something like GitHub, just to pick on them for a bit, I had written I don't even remember what I was doing at the time, but I had some kind of CI pipeline tool that I was writing in at Company Brain, where I think I wanted to check our branch names that we were building in CI and make sure they had a Jira ticket assigned to them or something like that. But I just did a really basic curl request over to GitHub and grabbed some data, and they return an array if you query repos. So I just piped it to JQ and got out the data I needed and moved along with my CI pipeline work. Until I came in a couple months later and started seeing this rash of errors in logs, cannot index object with number. What the heck is that all about? SSH into our CI servers, run the query, and realize that my API token had just expired after 60 or 90 days or something. And now instead of returning an array, they're returning an object. So what does user/repos return? Sometimes an array, sometimes an object. If they had always returned an object with a data or an errors property like GraphQL, this would be a lot easier to programmatically handle. Adding pagination is another point. I touched on that already. This is bonus Company 3 that I didn't actually mention at the start. Company Speech Bubble. This one is a Rails backend with a React front end, and I was doing some React work with some pagination buttons, trying to figure out how to add pagination, and it was acting real weird the way I picked it up, where you could just keep clicking next forever, and it never seemed to end. It would just keep giving you empty pages for infinity. And when I looked at the back end, it had an API that took a page number and then just gave you back an array for that page. As a back-end engineer, okay, I guess that makes sense. You asked for a page, I gave you your page of data, that's what you get. But as a front-end engineer, I kind of need to know the total number of records, how many records per page. Then I could calculate how many pages there are. I could tell if you're on the last page, so I could disable the next button. So I ended up having to ask for a change. Can we get in some of this pagination data? Which, had it been already returning an object with a data property, would not have been a breaking change, but now we have a breaking change to our API to add pagination. So starting with object is a good way to go. Again, the JSON API spec, if you start there, this is what they say, which is always return an object, must contain one of data or errors or meta, and you can't include both data and errors. It should be one or the other, which is exactly what GraphQL did. So that is a nice spec to start with, and what I would recommend that you do as well. Number 3 is to return errors in a consistent way. If we bounce back to the GitHub example, their response is actually pretty nice. We get a human readable string, we get a URL to their documentation, and an error status code, which happens to align with the HTTP status code, which is of course a good idea. There's already status codes defined, you could use them. This gives you a place then, instead of just relying on the HTTP response code, you could insert your own status codes if you wanted to define your own more granular errors. The things this GitHub could probably have improved here is to nest this underneath an errors property, so that at the top level you could just check to see if errors existed. The documentation URL could probably link specifically to the section on how the auth credentials work, since we know this was a bad credentials 401. And if you have an API where you expect a UI to be calling it, from a browser, the browser would pass an accept language header and tell you what language the browser is set to, so you could do I18N translations for the human readable strings as well, if you happen to think you're going to be called by a UI. At Company Egg, we've got a whole bunch of services, some of which take in JSON data that might expect a number, so number field should be a number. But customers being customers are going to sometimes pass the wrong thing. And so you got a standard HTTP code, response code of 400, bad request, that should cover that, right? No, you just cast it to an int, and when it blows up, you just blow up the whole server. This is not how you should handle errors consistently, even though you could consistently handle them by just returning 500. But then when you come in the morning and start looking at your logs, and all you see is server error, server error, server error, server error, you panic and wonder what the heck is going on, and if you have a mass outage on your hands because the servers are on fire, no, somebody just passed a string instead of an int. So what we did at Company Brain was a little nicer. This was started off as a Rails backend. We later moved the stuff along to TypeScript, but we just used the standard active record validation stuff, which actually returns a really nice response. You get an object with an error property, and then the properties underneath that are the field names that failed validation, with an array of human readable strings for all the validations that failed, which is a pretty darn nice format actually. And this is, I don't know what, 10, 15 years ago Rails had this, so good job to those guys. But it brings me into point 4, which is to try to be language agnostic, and this is why you should rely on your documented conventions instead of the conventions of your specific language or framework. This response is pretty good, but first name is always snake case because it aligns with the property name in Rails, and you might have other teams that are using camel case or a different case, so you could possibly clean this up a little bit by normalizing the field names. What's worse is at Company Egg, we have dozens of microservices in at least 4 or 5 languages, as I mentioned, and these are actual snippets of some requests, possibly responses, I forget which, from 2 different services. The one on the left has a data property, the one on the right doesn't. You've got camel case, snake case, all uppers, title case. What is even correct? On the left, you have application number. The service on the right takes application no. So they aren't even consistent names. And of course, the service that I happen to work on at Company Egg queries a bunch of other services, aggregates their responses, and passes it along to another service. And when one service is giving me a bunch of mixed cases and application number, and the service I have to pass it to is other cases and application no, well, this is how you do C# and end up in automapper hell. And mapping every individual field, you know, to map between inconsistencies. So I would propose that you should document conventions, pick a casing, probably camel case since it's JSON, JavaScript object notation, but pick one. It doesn't, have to make everybody happy. It should just be consistent. And pick common names for things. Application number should be application number and not application no for a different service, just because two teams decided to name things differently. Hence this slide. And adding to that documentation, also things like data types. If you have an application ID or an application number, is that a string or an actual numeric field? Is it a GUID? More importantly, date formats, because nobody can agree on a date format, and JSON doesn't have its own. So even at company egg, where we do sometimes have property name alignment between two services, sometimes one service will give me back an ISO 8601 string with year, month, day, hour, minute, second, millisecond, Zulu. And then the service I have to pass it to has the same property name, but they expect ISO 8601, just the date, year, month, day. And if you pass them the time component, they'll throw back a 400 or a 500 error. So we don't even have consistent date formats, which is quite the headache. And again, automapper hell. Number 5, one that you should do, but you probably aren't. And don't worry, GitHub wasn't either when they first started. In fact, if you look up the GitHub versioning docs, they still have up the banner that the REST API is now versioned from several years ago whenever they started doing versioning. Most of the getting started guides and little frameworks don't bother guiding you into having a version at all. But why is that important? Fortunately, it's not too hard to add a version later, but I would propose that you should probably start off with one because it costs you very little. And then you bump your version number when you have breaking schema changes. For example, at Company Egg, we had one particular service that really didn't like if you pass extraneous data to it. So if you pass it a field it doesn't know about in its schema, it just throws back a 400 bad request. So client app in this slide, or in the next couple slides, will be the app that I work on, and I'm calling some semi-problematic API that requires no extraneous data. Let's say we're making a change where we currently pass name and we want to pass a new required field, age. So this landed me up in a long Slack conversation because at some point we realized we don't know how to deploy this to production without causing a bunch of errors. Why is that? Because you can't deploy the server first. If you do, then the client hasn't changed yet, and you're not passing the new required field, so now everything is an error. Okay, so update the client first. Oh no, you can't, because if I start passing age, it's an extraneous data field. So we didn't know quite what to do or how to deploy to production without causing like several minutes of errors as we tried to deploy our apps at some kind of synchronized timeline, but these things can't be exact. And it landed up with me suggesting, we could have fixed this with API versioning, and I was met with a slight bit of resistance. To be fair to the person who commented to me, their service that they happened to work on their team did actually keep things with non-breaking changes. They did not run the problematic service that would kick out extraneous data errors. So I didn't actually have a problem with his service, but I had a problem with a service. So the way I would propose fixing this with versioning is you start at the top. My client application would be calling version 1 of said server API, passing name, everything is great. You add a new field by making a version 2 of your API, then you can deploy the server, which will contain version 2, but nobody's calling it yet because nothing's been updated to call version 2 yet. So everything is still great. Then I could deploy my client-side update, which not only adds the new required field of age, but also switches to version 2 of the API, and everything is still great. So we could do an actual production deploy in a correct known sequence without hitting a bunch of errors in production. I think in the end we actually just released them as close together as we could and dealt with the errors. But what do I know? So versioning, yes, you've seen it. You kind of know how it works. You typically end up with a version number in the path or something in the header. Either's fine. I don't really have a great recommendation. Curiously, Stripe has both, which is, I don't know. That's cool, I guess. I often get confused by the date version in the header. For some reason, when people do versions in headers, they love to use the date, and I don't know what that means. As an API consumer, I assume that every request after that date must adhere to the new version. Like that's the date that it must have flipped in production. But as an API maintainer, how do I know exactly what day this is going to go to production? And if our deploy slips, do I have to now update my version number because we deployed a day late? Like, it doesn't make sense. Maybe it's the date that the specification for that version was approved, but then as the API consumer, why would I know about that? So I don't know. It seems like an odd thing to use, but probably something most people just ignore anyway. So pick one, use it, be consistent, put it in your documentation. Whoa, but what about GraphQL, you ask, if you've done GraphQL? They explicitly tell you to don't bother with versions. Just keep things in non-breaking changes instead. Which, didn't we all just chuckle at when we said we'll just keep things non-breaking? Is that really a solid plan for the next 10 years of your API to not have any way to put in versioning if you need it? I'm pretty sure I could come up with some way of changing a mutation in GraphQL or just outright renaming a property that would probably cause some kind of change. And if you throw in like a /v1 in your URL, if you never change it for the next 10 years, it really didn't cost you anything past 10 minutes of your time, if even that. So I would probably still throw a version number in there just to be safe for later. Number 6, this is where I spent a whole ton of my life, sad and depressed. Infrastructure is code. We all love it because you're not cool unless you're DevOps and infrastructure is code. At least that's how it was 5 years ago. So for a lot of our API projects at Company Brain, we took our probably half dozen to a dozen API projects and started pumping our own infrastructure as code into them. This is some Terraform on the left as an example, but it could be whatever. And we did everything kind of soup to nuts deploy. This all happened to be AWS examples, but it would bring up the Route 53 DNS entry. It would make the SSL cert. It would bind it to CloudFront. It would bring up the load balancers. It would make an EC2 cluster, deploy the application code. You could go from nothing to everything in one deploy, which is awesome. Until you start going through 4 company renames and you have to start changing these domain names all the time, and now you have to change it in a dozen projects that all define their own infrastructure as code, which gets hard to manage. And also as you go through application rewrites, it becomes even more problematic. So at Company Brain, we started with legacy application, which is the top box, and it owned the domain name all the way down, brought up everything. At some point, I had a team that I was heading up that was doing application rewrites because this happened to be Rails backend running in EC2 clusters. And we were doing a rewrite over to TypeScript and serverless because serverless is also cool. So to start working on a replacement app, we just fired up a new GitHub project, started bringing over a lot of the same infrastructure as code stuff. We'll bring up our domain name, we'll bring up the SSL cert, bind it to CloudFront. We got our WAF rules in there, got everything we need. And at some point I realized that if we deploy to QA, we would take over qa.brain.com for our application. But we also have the production support team over there who's still dealing with the legacy app and has to do bug fixes for current production customers. And if they deploy, they're going to take over qa.brain.com. And now we have a conflict of just whoever deployed last wins. And sure, you could make the argument that the old app could use QA and we could use a different subdomain like QA2 or QA-next or something for the replacement app. But if you think ahead to production, this means we would have one hard flip of the switch where whenever we deploy the replacement app, it's going to blow over production and steal the domain name. And now all traffic for all of our enterprise risk-averse customers is all going to flip at once, which it turns out is not a good idea. More on that soon. So my recommendation here becomes to move off some of the common shared infrastructure as code stuff like DNS into a separate project that maybe an ops or a DevOps team can manage between different APIs that will plug into it. What we actually ended up with was something more like this, where we had a bit of shared infrastructure that owned the domain names, all 4 of them or whatever, deployed common WAF rules for everybody so that all the projects were consistent, and used an API gateway. Note for the next few slides, I use an AWS logo for API gateway. I actually am referring to the pattern of API gateway, not necessarily the exact AWS product. So that could be different things depending on your architecture. And then our actual applications would just spin up the infrastructure as code for the actual runtime environment they need, whether it's EC2 or Lambdas or whatever. That worked out a bit nicer. Which brings me to point 7. Don't assume that all of your requests are going to go to the same application. You could be routing traffic to different places, especially as your APIs evolve and you start doing application rewrites, you start adding more API projects. Using something like an API gateway pattern to look at and route traffic works out a lot better. At some point at Company Brain, somebody realized that flipping the switch and moving all of our risk-adverse customers to the new system at once would be a bad plan, because if that blew up, boy, are we going to be in a world of hurt. So what we actually ended up having to do was, for each individual customer, we would get an engineer, a QA person, a rep from that company, the account manager, a support person, all on the phone at the same time at a planned night, flip the switch for that one customer at a time, run some test traffic through to make sure their integration didn't break, and then we could call them good. Which is how we ended up writing our own API gateway. In our case, we wrote our own, which I think we just called application router. But it would basically just look at the auth token or whatever that was coming in, figure out what client this was, pull their record out of the database, see if the migration flag had been flipped for them, and decide to proxy to one of the other two applications. But if you land up at some kind of API gateway, and this could be AWS API gateway, it could be something you write yourself, it could be Istio if you're in the Kubernetes space, it could be an Nginx reverse proxy that just looks at the path and routes based on a version number. You can start doing some cool stuff with your deploys. You could start doing A/B test deploys, where you have an old version and a new version, bring them up side by side and route traffic as a percentage. Canary deploys, blue-green deploys, routing per tenant, routing per version. You could have version 1 and 2 routing to a legacy app and version 3 of the API route to a new app, all transparent to the customer without them having to actually change domain names all the time. And in Company Brain's case, and big old enterprise customers, they move at a glacial pace. So if you asked them to change the domain names, well, that's going to be like a month of planning for their IT teams to do. So that's kind of where we landed up there. If you're in the GraphQL space, you can do something similar. We also had GraphQL APIs at Company Brain. This is where we kind of had multiple applications behind the scenes, but wanted to expose one nice API layer to the customer. You can do federated GraphQL, where that GraphQL gateway layer will grab the schemas from the lower applications and make one big aggregate schema, and then it'll look at the queries and mutations that you're calling on it and route them out to the different sub-applications, aggregate the responses, and hand it back to the customer. So it all ends up transparent to the customer. The whole thought here is to just keep moving common functionality forward. You could start having an API gateway that does some initial token authentication. If you want to bring in a JWT token and at least check the signature on it to make sure that it's cryptographically signed still. This is a great place to start adding in some built-in basic observability stuff. You can catch request rates, failure rates, and durations of all the requests at this upper layer, and then every API you plug into it in the future, you no longer have to implement that stuff. Rate limiting I always find interesting. If you happen to have licensing that has some kind of rate limiting, like you get 100 requests per hour or something, can you possibly make 100 requests to version 1 of the API and 100 requests to version 2 because they happen to route to 2 different applications behind the scenes? Maybe rate limiting could get handled up front between the applications that they get divvied down to down the stream. So things like that, basically things that all of your services should do consistently. If you can push those forward, then as you rewrite or add new applications, you don't have to keep re-implementing the same thing or copy-pasting them forward. One such thing, as I started to mention, observability. So plenty of times we'd ship an API to production and then come in the next day, grab the next Jira ticket off the queue and go back to work and never think about that old API again. I assume if it's not working, somebody will probably contact customer support, which will probably contact engineering, and I'll probably hear about it. But what would be nice is to actually know if our API is up and running, if it's hitting a bunch of errors, if we're meeting our contractual obligation SLAs to customers, things like that. It's also kind of nice if you can walk into your every 2-week sprint retrospective or quarterly review and show a big ol' graph and say, here's all of our metrics, here's where we're meeting our SLAs, here's outages we had, here's our average response times. People have a pretty graphic to look at and get excited about that kind of stuff. At Company Brain, we had decent metrics. We never got into tracing because we killed our Datadog spend before we got there. But if you Datadog, you know. I had built a nice piece into our GraphQL layer that would start a metric, just a duration metric, but then tag it with what queries and mutations were being called in it, and then also tagged if it resulted in an error or not. And that gave me a pretty good starting dashboard that then everybody else adding to our GraphQL schema didn't have to worry about. Until somebody decided to refactor the code and deleted all my hard work, and I will be bitter about it forever. At Company Egg, we actually have probably the best dashboarding and tracing I've ever seen. It's pretty awesome. I wish I could share a bunch of their example dashboards, but it's really hard to obfuscate sensitive data out of their stuff, so I couldn't share a lot. But it's gotten to the point there where I can get production reports, like issue reports from people, say this customer's having an issue with this order ID, and I can plug the order ID into like a Datadog dashboard and see every API request that happened for that customer, in what order they happened in, what the duration was, what the HTTP response code was, see what downstream services were called because of the tracing, see if any other services returned errors. So one way to do that is to add dimensionality to your metrics and trace data. If you Datadog, I think they call it tags. I think AWS CloudWatch calls them dimensions, and I stole this slide from AWS reInvent presentation. Thanks, AWS. So this is basically dimensionality in a nutshell. Show me some metric divided up by some dimension. I want to see requests to a path. I want to see latency for a version, whatever. How do you do this in reality? This is an Express.js example of how I would do it, just using a middleware. Really, the function on the right is probably an important one. I'm just grabbing a bunch of data from where I know it might be. We've got the current environment, whether it's production or QA or whatever, in an environment variable, grab the path off the request. If we know that we're using versions in the header, I could just grab the version right off the header and add it to the metric tags. If we're putting the tenant ID or customer ID in a consistent place, we can add that easily. And then I start off with an error state of false, and I have a try catch over on the left where if the thing responds with an error, I'll just mark it as such. If you're a .NET person, ASP.NET has action filters that can plug in and get called before the actual request handlers. There's not a whole lot on this slide other than it calls add data to scope, which is on this slide. This just loops over the incoming request object and uses some reflection to check for any of the property names that are on the very first line in array. So if the incoming JSON object has user ID or account ID or customer ID or order ID and I can find it via reflection, I will stick it onto my trace span so that later when I'm looking through Datadog traces, I can see exactly which customer this span belongs to and exactly which order this span belongs to. Which helps massively in troubleshooting production issues. So, sorry to go light mode on you suddenly, but this is kind of some somewhat obfuscated dashboards and some examples of things you can do if you have your observability data divided up nicely. You can do response durations by path, and if you had this thing up on a wall in the office, you'd immediately see that orders update is blowing up right now. It's like 90-some% errors. You got the average durations for everything, but we know right away how many requests are coming into each endpoint. We know if somebody's not using certain endpoints. We know if they're performing poorly in terms of their duration. You can do things like usage by customer. Who's even using our API? Well, we can see right away how many customers we have using the API and how much they're using it. API errors by customer is kind of a cool one, because if you come in the morning and look at your logs and you've got a big rash of red, okay, is it one customer spamming us with some automated process that has bad data in it, or are all the customers exploding and we have a giant outage on our hands? How hard do I need to panic right now? You can kind of judge that by looking at the API errors by customer. And in this particular graph, there's like 2 customers that are spiking in errors. So I could just get maybe an account rep for that customer if it's an enterprise level thing, and maybe see what the heck they're doing, see if they need some help using our API or what's going on with them, and try to get their situation resolved. API request by version, since you have your versioning set up correctly, is a nice one to know when you can deprecate old versions. In this case, we still have people using version 1, even though we're on version 3. Why are they doing that? So how many times I've had to go to like a product rep and be like, hey, is anyone still using version 1? Do you know who's even using that thing? I see there's some request to it, but can we get them off of it? I don't know who's calling it, somebody. If we have all of our data already partitioned up, we could just say request for version 1 by customer, and you could essentially get the graph in the upper left for a specific version. And that data is all there, it's all tagged, you don't have to do anything to your application code, it just is there. So, number 10. This is something that I haven't actually done much of myself, but is something that I will probably play with in the future. And that is considering item potency for customer requests. Stripe is one of the only APIs I've seen that actually does this. I checked both FedEx and UPS, assuming they might do something like this, but they both don't. And so this is the thought that if your customer calls your API with the same request or with the same item potency key in this particular case, you'll just not do anything other than return the same canned response that they got last time they called you with the same item potency key. Why is that important? Well, we live in a world where microservices and event-based architectures are more and more common, and in most event-based architectures you are guaranteed at least once delivery, but not only once delivery. So let's say we have order service here that processes a message out of the queue, calls a payment service, perhaps it's Stripe, collects payment from a customer, then calls off to the shipping service, maybe it's UPS or FedEx or something, to generate a label. They return an error. Okay, what does their order service do? Well, in a message-based architecture, we can just dump that thing back into a dead letter queue or a retry queue or an error queue or whatever. And maybe 10 seconds from now, we'll just run it again to see if we get a good response the second time. Maybe the shipping service was just down temporarily. So if we process the order a second time, order service will yet again call the payment service to try to collect payment, which it already did once. So now maybe we're double charging the customer, and maybe the second time through the shipping service works. So we'll ship them one thing and bill them twice, maybe. With Stripe, you could pass the message ID out of your messaging system as your item potency key, and the second call to withdraw payment would just return you the same response as last time, but not actually do anything, which I think is kind of cool. And even without the error case, like I said, most message queues are guaranteed at least once delivery, but there's no guarantee for most messaging systems, even without an error case, that order service couldn't process the same message twice. So there you have it. Those are my 10 things that caused me a whole lot of pain and suffering over the last several years that I would argue you could consider probably doing some of these, maybe not all of them, up front, and save yourself some headaches in the future. And we are a few minutes ahead of time, actually. This is the fastest I've ever gone through this talk, so that's cool, because we're up against lunch, and I'm sure you're hungry as I am. So we can all get out of here and go do some lunch. Please thank your sponsors. If you guys aren't in the loop on with people that run conferences are struggling over the last couple of years with a downturn in software and people not wanting to put up money for conferences. So please thank your sponsors. They are what make this possible. I'm going to skip Q&A so you guys can go eat lunch, and I can go eat lunch. But we have a Slack channel if you want to ask some questions there. Otherwise, thank you for coming. Go eat.